students, today we are going to discuss about the construction and working of shell and tube heat exchanger. Construction and working of shell and tube heat exchanger. Before discussing the construction and working of shell and tube heat exchanger, just we recall once what is double pipe heat exchanger and what is its limitation. Double pipe heat exchanger already we have discussed in last class. It consists of two pipes. One is inner pipe and the other is outer pipe. So suppose hot fluid is flowing inside the inner pipe and cold fluid is flowing in the annular space. Now heat transfer takes place from hot to cold fluid like this. Now suppose the length of the tube is 10 feet here. The length of the exchanger is 10 feet. And suppose the diameter of the this inner pipe is 1 inch, that is 1 by 12 feet. Then what is its surface area? What is the surface area? A naught equal to pi d naught L. It comes to 2.62 feet square. So this surface area of this DPHE is limited. So only this much surface area is available. So what is the limitation of double pipe heat exchanger? Less area, only up to 100 feet square we can handle. And also another limitation is because its length is fixed, diameter is fixed, everything is fixed. So it handles less amount of fluids only. We cannot handle very large amounts of the fluids. So these are the limitations of the double pipe heat exchanger. Then how to overcome this limitation? How to overcome this limitation? Suppose each tube surface area is 2.62. If you use 10 tubes here, suppose 10 tubes into 2.62, that how much it is coming? It's more than 20 feet square. So all this 20 feet square area can be packed in one outer pipe. That is the modification of this double pipe heat exchanger. Okay, modification of the double pipe heat exchanger to overcome the limitation of less area. How is it modified? Outer pipe is one only, that is called shell here, but inner pipe not one but a number of tubes or a bundle of tubes, say 10 or 15 or 20, like that. A bundle of tubes are packed in a given shell. So one outer pipe and a number of inner pipes. That is the basic construction modification of this double pipe to bring the new design of shell and tube heat exchanger. So we have increased the surface area of the heat exchanger. That means surface area, available surface area is the main thing to have a large value of Q. So we have increased the surface area in the same given space. That is, length of the tubes are not increased. Okay, so space is same. Suppose double pipe heat exchanger, if you want to increase the surface area, what we have to do? We need to take a very long double pipe heat exchanger. It is not possible practically to install that much lengthy exchanger. Or else another way is what number of double pipe heat exchanger must be fixed in series, like or in one above the other, something like coil type or like that. We in the shape of coil also we can modify the double pipe heat exchanger. But compared to all these designs, this shell and tube is a very important design which we use in process industries. Shell and tube heat exchanger is very important heat exchanger design which we use in process industries, because in process industries it's very important to heat or cool the fluids. Okay, to heat or cool the fluids from one temperature to the other temperature. We need to change the temperature of the fluids. So this is the shell and tube heat exchanger. We'll discuss 2-3 points about the construction. This is called shell. Only one shell here. This is a shell. And these are all tubes. These are tubes. Here. So these tubes are fixed inside the shell. How does these tubes are fixed inside the shell? Simply we can't hang these tubes, isn't it? So 2 tube sheets are used. 2 tube sheets. 2 tube sheets are used to fix the tubes to the shell. To fix tubes to shell. Okay, one tube sheet at the entrance, the other tube sheet at the exit here. So at the 2 ends here, these are called tube sheets here. See, this is one tube sheet, this shaded portion, this is tube sheet. Here also shaded portion, this is a tube sheet here. Here it is written. So this tube sheet, suppose here one tube sheet is taken and this tube sheet holes are drilled here. Why to drill the holes here? Because we need to keep the tube into it. We need to fix the tube into it. Okay, like this. So what must be the diameter of the hole here? It should be slightly greater than outer dia of tube. Okay, that is dia of dia of opening. Dia of the opening, which has to be drilled, should be slightly greater than the OD of the tubes. Like that, several number of, suppose 15 tubes we need to fix. 15 holes are to be drilled in the tube sheet. In the same way here also. Then these tubes are fixed into this tube sheet, and care will be taken to avoid any leakage and all that. They will be properly fixed. And the ends of these tube sheets are fixed to the shell. The ends of the tube sheets are fixed to the shell. Okay. So this is about the shell and tubes. And what else we can see here are, here you can see these lines here. This you just observe from here to here. One. Same thing like that, several. This is nothing but one plate. And also fixed from here, it is fixed to the shell and ending here. And another one is fixed to this, the other side, and ending here. These are called 25% baffles. These lines are called 25% baffles. What is the purpose of 25% baffles? What is 25% baffles? We will see. 25% baffles means nothing but a circular plate. A circular plate. 1/4 of it is cut. That means suppose it is a plate like this. Okay. And 1/4 of it is cut. So this is a baffle plate. This is because 1/4 we are cutting, it is also called 25% baffles. It is just a plate. It is nothing but one plate with 1/4 cut off. That is why this 1/4 space is left here. And this also here because these tubes have to be extended into these tubes. Here also the holes are drilled into this baffle plate also. Okay. So what is the purpose of this baffle plate? The purpose is to promote cross flow. To promote cross flow. to promote cross flow. That means to promote cross flow means to increase turbulence in the shell. Okay, to increase turbulence in the shell. If turbulence is increased here, heat transfer coefficient H0 also increases. So that is the purpose of this. We will discuss what is the necessity of increasing HI and H0 after some time. Okay, so here this is the basic construction, and inlets are there, outlets are there, and here any drain is there, anything is to be drained, some drain is there. This is the construction, basic construction of shell and tube heat exchanger. Now we shall see the working. How does it work? Any heat exchanger handles two fluids. Okay, one is shell side fluid, and the other is tube side fluid. Any heat exchanger handles two fluids. One is shell side fluid and the other is a tube side fluid. Shell side fluid means fluid which flows inside the shell. And tube side fluid means fluid which flows inside the tubes. So we should always remember these terms: shell side fluid and tube side fluid. Now here, which one is shell side fluid? Shall we identify this shell side fluid? This is a shell, isn't it? This is a shell, means surrounding the tubes the fluid flows here. Which fluid is entering here? Which is the inlet of the shell side fluid here? This is the inlet of shell side fluid. This is the inlet of shell side fluid. Okay. Now after the shell side fluid enters here, it occupies the complete space inside the shell, that is outer the tubes, inside the shell and outside the tubes. That all complete space will be occupied by this shell side fluid, and it flows. The fluid's property is what? Wherever there is a space available for it, it tries to flow in that way only. So here, after entering here, it can't go anywhere else. So it has to take a turn like this, flows like this, and will be leaving. Here all closed. Here this is open again. So here it will be leaving. So this is outlet of shell side fluid. Okay, so shell side fluid enters here, flows through the shell, and then will be leaving. Next, tube side fluid. Tube side fluid is what? The fluid which flows inside the tubes. So where is the entrance here? This is the entrance, inlet of tube side here. So after this tube side fluid enters here, what is the space available for it to occupy? From here to here, this whole space is occupied by this tube side fluid. After entering here, then these tubes are opened, it enters like this. So tube side fluid occupies this entire cross section and will enter all these tubes and will be flowing here through the tubes. So enters here, flows through the tubes and will be leaving. This is the space available. So this is the outlet outlet of tube side, outlet of tube side fluid. So leaves like this. Okay, this is how hot fluid or with, here we are not deciding which one is hot and cold. Oh, out of these two fluids, shell side and tube side, one is hot fluid and the other is a cold fluid. So this way hot and cold fluids are brought into contact. Here once again shell side fluid enters here, flows inside the shell and will be leaving, and the tube side fluid enters here, then after entering this chamber enters all the tubes, flows to the other end and will be leaving here. This is outlet of the tube side fluid. So in these tubes, these two fluids now are separated physically. The two fluids, shell side fluid and cold side fluid, are physically separated but thermally in contact. Okay, physically separated but thermally in contact. Okay, so as the fluids passes along the length of the tubes, heat transfer takes place. Then while leaving, suppose if shell side fluid is hot, here this will decrease. Then tube side tube side fluid is hot fluid, then here it will be losing. Then this will get heated. One fluid loses heat, the other fluid absorbs that heat. Like that heat transfer takes place between hot and cold fluids. Okay. So this is a simple design of shell and tube heat exchanger, and this design is called single pass 1-1 counterflow heat exchanger. Why is it called like this? Is single pass means only once each fluid is passing through the exchanger. That means shell side fluid is passing how many times through the exchanger? Here shell side fluid is entering here, flowing to the other end and will be leaving. Only once it is flowing. Only once. So single pass 1-1. Then tube side fluid is entering here, flowing to the other end and then leaving. Again it is not taking any turn. So this is tube side passes also 1. So that is why it is called 1-1 counterflow heat exchanger. When we discuss 1-2 and 2-4, no, that we will discuss what does this number indicates. Okay, since shell side is passing only once, tube side is also passing once, it is called single pass 1-1 and it is counterflow. So it is hot shell side fluid is flowing this direction and tube side is flowing this direction, opposite to each other. That is why it is a counterflow heat exchanger. Okay, single pass 1-1 counterflow heat exchanger. It is simple design and also a good design, but again it has got some limitation. What is that limitation and how to overcome it?